Connor, how are you doing?
I'm doing good. How about yourself?
Good. Happy New Year to you.
Well, you too.
So, what are we going to work on today?
Solving polynomial equations in factored form.
Okay.
So,
Sounds like that's
it's for
something
me.
you can verbalize.
Yeah, for the most part.
Okay.
So let me just give you the first one.
Uh-huh.
Okay. 5z to the second power, exponent of 2, sorry, plus 45z. And that's it.
Okay. And we're just supposed to factor this?
And then solve for the factor.
Okay. The very first thing you do is see if you can find a greatest common factor.
Okay.
So what's the largest entity that divides into both that and that evenly?
5.
5z.
5z, my bad, sorry.
It's all right. And after you divide 5z into each of those quantities, what are you left with?
Let's see, so, 0, right?
Oh, this one would be z, and that would be 9. And let's make sure you understand why.
Okay.
After you factor it, you have to make sure that if you multiply this by that, you get what you started with.
Okay.
In other words, when you're doing division, it's the inverse of multiplication. So whenever you're dividing something, even if I divide 45 by 9 to get 5,
Mm-hmm.
the last thing I think about is to make sure that 5 times 9 is equal to 45.
Okay.
So that's a key part of division. And that's what factoring is division. In other words, this is the greatest common factor, 5z. And when you divide 5z into 5z squared, you get z. And when you divide 5z into 45z, you get 9.
Okay.
So this is how it factors. But always make sure that when you multiply the two factors back together again, you get what you started with. That's the key to doing division or factoring.
Okay.
What's the next one?
Don't we have to solve for the factored form too?
All right. When it says solve for the factors, these are our two factors right here. Now, if the original expression was actually an equation like that, well, then it means that 5z times z plus 9 is equal to 0. And is that what the problem was?
No, but I think I'm confusing myself. I'm sorry.
Normally, you got two different things. You got expressions and you have equations. That is an expression. You can factor an expression. We factored that expression into 5z times z plus 9. However, if the problem was, okay, here's an equation to solve, now I still solve this equation by factoring this expression and having it equal to 0. The number one theory, or theorem rather, of algebra is that if you multiply two things together and get 0, then either one of those things can be 0.
So would you subtract the 9 then?
Well, what I would say is that either 5z has to be equal to 0 or z plus 9 has to be equal to 0. So let's start with the first proposition. 5z is equal to 0. Well, divide both sides by 5 and you get z is equal to 0. That's one solution. The next part is z plus 9, this part here, equals 0. Subtract 9 from both sides, and you get z equals minus 9. That is your second solution.
Okay, that makes sense.
And it's a subtle distinction as to whether you start with an equation or an expression. In other words, if I start with just that expression and I say factor it, well, it's 5z times z plus 9. That's the answer. But if I start with this being equal to 0, which frequently it is, and I say solve for z, it's a different problem. You still have to do the greatest common factoring, but it's still a different kind of problem.
Okay.
What else you got?
Okay. 60 with the exponent of 2 minus 21d.
21 what?
D.
That it?
Yep.
We're supposed to simplify that?
Yes.
Okay. Well, again, we're going to look for the greatest common factor. One of the things we could do is go ahead and multiply this out.
Okay.
So what's 60 squared?
60 times 60.
So that's 3,600
Oh, okay.
minus 21d. Now, looking at this expression, what's the greatest common factor? It's not that easy to figure out, but you can do it.
Wouldn't it be 7?
Well, 7 is a possibility because 7 divides into 21 evenly. But does 7 divide into 3,600 evenly?
No.
No, it doesn't. So what's another factor of 21?
21.
Correct. But when you said 7, what multiplies by 7 to equal 21?
3.
Okay, so 3 is a factor of 21. Is 3 a factor of 3,600?
Yes.
Yes, it is. So let's start with 3. And the way you can do these is you can start with what you think is the answer, and you'll quickly discover whether it is or not. Okay. What's 3 into 3,600?
I'm using a calculator.
Yeah,
so
you should always have your calculator handy when we're
okay. 1,200.
Right. Okay. What's 3 into 21?
7.
So now that's the answer unless we can find a number that goes into both 7 and 1,200. And
What?
we can't.
No.
7 only has factors of, 7 is prime, so it only has factors of 7 and 1. And 7 does not go into 1,200.
Okay.
So we've got our answer. That's it.
Awesome.
And again, if this was an equation, if we go back to the beginning and set it equal to 0, then this would be equal to 0. Well, now I can set this equal to 0 and solve it. And that would be the way I would solve for D.
Okay. Awesome. Okay, 3y to the exponent of 3 minus 9y to the exponent of 2.
Okay?
Okay, so would it be 3?
No. Let's look for the greatest common factor. 3 is the greatest numerical common factor.
Oh, 3y?
3y squared.
Squared.
In other words, look for your variable that is the greatest exponential variable that divides into both of these.
Okay. So the exponent doesn't have to be even?
No, it does not. In other words, if I look at this, the only thing we need is for that to be even.
Okay. So basically it's the smallest number.
Yeah, when you're dealing with the variables, yes. Although, I mean, if the problem was, say, this, the greatest common factor there would be y to the 1/4.
Okay.
And it would leave y to the 1/4 plus 1. Okay? So it's not just the lowest number, although I suppose this was a bad example for me to use because this one indeed was the lowest number. But say make that 2/3.
Okay.
Now, y to the 1/4 does not divide evenly into y to the 2/3. So it's not just the lowest number.
Okay.
It has to divide evenly. That's what factoring is all about, is dividing evenly.
Okay.
So when I factor out a 3y squared, what am I left with?
Y to the second power. Oh, the 3, right?
Uh-huh. There's your answer.
Okay. So,
Uh-huh.
never mind.
That's all right. No, whenever you have a question, be sure to ask.
I was I was a little confused. So you don't, because I know when you had the when you're just showing me some examples, and if it was like y and 1/4 or something, you had it on the outside of the parentheses, and then when you had, for example, the y inside the parentheses, it had the exact same exponent.
Let's see. So I had y to the 1/2 plus y to the 1/4, and I said let's factor out the y to the 1/4, leaving behind y to the 1/4 plus 1. Is that what you meant?
Yeah. So.
So what's the question here?
Well, when you had the 3, the 3y second power.
Okay.
Because I know it's y 1/4 on the outside, 1/4 on the inside.
When you multiply the same base with different exponents, you add the exponents.
Okay, that makes sense.
That's
That was my
the
question.
key.
I'm sorry.
In other words, the key as to whether this is the right answer or not is when I multiply it back together, do I get what I started with? Well, when I multiply y to the 1/4 by y to the 1/4, I get y to the 1/2. And when I multiply y to the 1/4 times 1, I just get y to the 1/4.
Okay, my bad.
That's the same as that. That's what's necessary.
Okay.
Okay? Yeah, there's a
Sounds
rule
good.
of exponents. Let's talk about that. If I have b to the a times same base b to the c, then that's equal to b to the a plus c. For example, if I had 2 cubed times 2 to the 4th, what would that be?
It would be 4. No, sorry. Yeah.
No, the b doesn't change. So it's critical to leave the base alone. So it's 2
And then 3 plus 4.
to the 7th. Exactly. Okay. Now, if I have a different base, I can't do anything to simplify it. If I have this, well, the 2 is not the same as the 3, so I can't just add the exponents. In fact, I can't simplify it. So these rules for simplifying exponents only work if your base is the same. Now, if I have b to the a divided by b to the c, then that's equal to b to the a minus c. For example, 5 cubed divided by 5 squared equals what?
It would be 1, right?
5 to the 1.
5 to the 1. I'm sorry.
That's okay. In other words, 5. In
Okay.
other words, you carry forth the base. I don't ever change the b. That b stays the same. just like I didn't
Okay.
change the 5. Okay? And there's one last rule for exponents. B to the A all raised to the C power is equal to B to the AC. For example, 2 cubed all raised to the 4th power, what's that equal to?
It would be 2 to the which would you multiply the 3 and the 4 then?
Uh-huh.
Okay, 12 then. Okay.
Okay, those are the 3 rules of exponents. Memorize those 3 rules and it'll take you a long way. Okay? And it applies to variables also. In other words, if I had x squared times x cubed, what does that equal to?
It'll be x, and then you multiply 2 and 3, right?
No, you add them.
Oh, add them. I'm sorry. So let me 5.
Remember, you always do one level less than what is being done to the base.
Okay.
If the base is being multiplied, we're going to add the exponents. If the base is being divided,
you subtract, right?
Exactly, because subtraction is one level less than division.
Okay.
And if the base is being exponentiated, well, or you could call this double exponentiation if you want. But when you do exponentiation, the level that is one less than that is multiplication. So that's the best way to remember or memorize your rules of exponents, is do one level less with the exponents than you're doing with the base. And the bases have to be the same. Now, there is one other thing that I don't want to confuse you, but if the bases are different, but the exponents are the same, then I can multiply the 2 bases and keep the exponent. So there's another situation. Same thing with division. If I have 5 to the 4th divided by 3 to the 4th, that is the same as 5/3 to the 4th.
I have a question. It sort of relates, but it's a little different. So I know, like, when you simplify an equation, and if you have like 5 to the exponent of 2, or 5x to the exponent of 2. I'm sorry.
5x to the exponent?
And then you'll have like another x. When do you add on to the exponent, and when do you add on to the actual number? Because I know if it's like 2x, it'll be like 7x.
In other words, you cannot, if I have x squared, let's say I have 5x squared plus 2x. Cannot add those. This is an apple, that's an orange.
No.
The only thing you can do is multiply and divide. Always think of multiplication and division as being the easier of the 2 things than addition and subtraction. It is much tougher. Let's just talk about that for a moment. Think about fractions. What's easier? To multiply those 2 fractions or to add those 2 fractions?
Multiply.
Yeah, by far. You just multiply tops, multiply bottoms. To add the 2 fractions, I got to come up with this procedure called finding a lowest common denominator, converting each fraction to that denominator, and then adding the numerators. So always remember that multiplication and division is easier than subtraction, and that includes when you're talking algebra. I cannot add these 2 things. They are different. But I can multiply them. If I multiply them, I merely add the exponents. What's the new exponent?
2. Or no, 3. I'm sorry. So it'll be 6. Okay, that makes sense.
Same thing with division and subtraction. If I have this, I can do nothing with it. But if I have this, I can, same base, different exponents, I can subtract the exponents and I get this.
Okay. Sounds good.
All right, what's the next problem you have?
20x to the third power plus 30x to the power of 2.
Okay, when we're looking for a greatest common factor, let's talk about numbers and then let's talk about variables separately.
Okay.
What's the greatest number greatest common factor?
10.
What's the greatest variable?
2, right?
X squared.
Oh.
That's what you meant to say, I know.
Yeah, my bad.
10x squared. In other words, if we treat it differently, it's really a simple problem. We're just trying to find the greatest common factor between 20 and 30, and then we're trying to find the greatest common factor between x cubed and x squared. Now, after I factor that out, what am I left with?
10x.
Hold on, and make sure that before you answer, you do the multiplication to make sure you get this thing.
Oh, 2. I'm sorry.
There you go. 2x.
My bad.
That's the way to do division, believe it or not. The way to do division is to subconsciously turn it into a multiplication problem. Before you write an answer on a test, whenever you're doing a factoring problem, make sure you multiply it back together to get, that's the key. That's what tells you that you've done it correctly.
Okay.
Goes over here.
Would that be the 10 divided? No, yeah, 10 divided by 30.
30 divided by 10.
Oh, my bad. So it would be 3x, or just 3.
Now, which is correct?
Wait, sorry, can you say it one more time?
Is 3 correct or 3x correct?
3.
Exactly, and the reason I know is because when I multiply that by that,
You get
I get
30x.
that, and that's what I want, is 30,
Okay.
30x squared. So as long as you do that step, you won't make mistakes. If you fail to do that final step, it's real easy to make mistakes.
Okay. Okay. 5n to the power of 6 plus 2n to the power of 5.
What's the greatest number that can be factored out?
1.
Yeah. Okay. No, you're right. There isn't a number greater than 1. So I could write it, but I don't need to. What's the greatest variable that can be factored out?
5. X and 5.
N to the 5th power. Let's go ahead and erase that 1. It's unnecessary. What's left?
Let's see, 5, right? 5n to the power of 5.
Hold on. Is that correct?
No, you won't need the power.
That's correct. Okay?
Okay. And then it'd be plus, 2.
Good.
Okay.
Pie, come here. What are you barking at? Come here. Come here. Okay, what else you got, Connor?
12a to the power of 4 plus 8a.
What's the greatest number?
Would it be... No, not 6. 4?
What's the greatest letter?
Be 4. Or letter? Yeah, 4. No, A. My bad.
It's okay. Don't apologize. You're getting them right. You're just having to think a little bit extra on them. But there's nothing wrong with that. You're doing good. You're doing fine. What goes here?
Okay. That'd be 3. 3A. And then we plus 2.
Hold on. Is this times that equal to that?
No.
Okay.
You need the
So that
exponent.
can't be correct. So what else do I need to do here?
You have to add the exponent.
Which,
no.
yes,
Yeah.
which is which? What's the exponent?
4.
Is that correct?
Yes.
Remember, there's a hidden exponent of 1 right there.
Okay.
So what is this proper exponent?
Would it be 1? 3.
You see why?
Oh, right. Yeah, because you have to subtract.
Well, no, you have to add. 1 plus 3 equals 4.
It's 4. Okay.
Okay? In other words, I'm doing all of these division problems as multiplication problems. I'm skipping the division and just putting an answer down and making sure that this times that is equal to that.
Okay.
That's the way I do division. Why? Because it saves me a step. I could do the division, but if I do the division, I know I'm going to have to check it by doing the multiplication, right? Well,
Right.
so I just skip the division step and I go straight to the multiplication step.
That's smart. Okay.
Well, it's one way to do it. Everybody has their different way of doing math. So what's this term right here?
2.
Exactly. And we didn't even do division. We just knew that 4a times 2 is equal to 8a.
That's okay. Okay. These are equations.
Okay.
So 4p to the power of 2 minus p equals 0.
All right. Now, this is different. This is an equation as opposed to an expression. But the solution is the same. The solution involves factoring the left side of the equation.
Okay.
The biggest number I can pull out?
1.
What?
Right? Oh, no, I'm sorry.
No, you're right.
Really?
Sure.
Okay. Okay.
Okay. Remember that the biggest number has to divide into both numbers, and there's a 1 in front of that p.
So it would just be p?
It would just be 1 and p.
Oh.
In other words, the biggest number was 1. The biggest variable was p. Okay, and now we don't need to write the 1. We don't write the 1. Unfortunately, not writing that 1 gets an awful lot of people in trouble with math. Math would actually be a lot easier if we didn't hide the exponent and we actually wrote it like that, because then people wouldn't forget that it's a 1 there. You know what I'm saying?
Right.
And the only reason we leave it off is by convention. I don't know. Maybe in Russia they write it. I'm not sure.
Right.
But okay, so what's left?
Okay, so 4p minus 1.
Okay, all of that's equal to 0, and we multiply that by that. Yep, that's what we get. So we did it right.
Okay.
Now, what is our two solutions?
Okay, p equals 0, right?
That's for this part here.
And then, let's see, we're going to want to add 1.
Well, first of all, let's take the first basic step. 4p minus 1 also must equal 0. Let's start there. You were just a step ahead of me.
Okay.
Now we add 1 to both sides. And what's the final step?
Divide by 4. So it'll be p equals to 1, 4.
So this one had two solutions.
Negative 1.
No, positive.
Oh, no, my bad.
Everything was positive.
My bad.
But the other solution was p equals 0. So this had two solutions, and it should have two solutions because that is a quadratic. Quadratics have two solutions. Linears have one solution. If I say p plus 3 equals 5, that has one solution, p equal 2, and only 2. That's a linear equation. P is to the power of 1 only. The moment I start talking about quadratics, and you have quadratics whenever your variable is to the power of 2, you're going to expect two solutions. always. Now sometimes both solutions are the same, but the fact of the matter is that quadratics have 2 solutions. Guess what? Cubics have 3 solutions. If I gave you an equation, I know you haven't talked about cubics yet, but if I said x to the third plus x squared minus x plus 10 equals 0, I would expect 3 solutions here. Why? Because it's a cubic. Quartics,
Okay.
4 solutions. So a polynomial has the same number of solutions as its highest degree polynomial. Now, at this point, the only thing you're talking about is quadratics. That's fine, but just be aware of the other. Because the one thing is that know that when you're working with a quadratic, you're going to expect there to be 2 solutions.
Okay. Okay, the next one is 6m to the power of 2 plus 12m equals 0.
Factor it.
Okay, so it'll be 6m, and then on the inside it would be 1, or just m.
Now those are different. That's okay. You eventually get it. Your first answer is usually wrong, but your second answer is almost always correct. So it's almost like I can see your brain working.
Okay.
But just know that 1 is not the same as m. In other words,
So it'd be 1m?
no, if I were to have written a 1 there, that does not work. 6m times 1 is 6m. It's not 6m squared. So I have to put an m there.
Yeah.
That's the only correct answer, and yes, this one is 2.
Okay.
So what's the next step?
Okay, so we'll know that divide by 6 then.
Okay, so let's go through the way I like to do it, and I'm going to advise this to you. When you get to this step here, you've got 2 things multiplied together equals 0. So let's take the next step of saying that means 6m equals 0 or m plus 2 equals 0. Now, it's key to understand they don't both have to equal 0. The theory of algebra says that you can't multiply 2 things together and get 0 unless one of them is 0. So the theory of algebra merely says that one of these things has to be 0. The way we actually do solve these is to set both of them equal to 0. Well, if 6m equals 0, m equals what?
Negative, no. 0?
Uh-huh. And if plus 2...
It's like the number doesn't even matter.
What's that?
So it's kind of like the number in front of the m doesn't really matter.
What I'm doing is dividing both sides by 6, and when you divide 0 by 6, you still get 0. And then m plus 2 equals 0 means m equals what?
Yeah. Negative 2.
There's your 2 solutions.
Okay. Okay, 25c plus 10c to the second power equals 0.
The biggest factor that?
Would be 5.
That's the number. What's the letter?
The letter would be 1, C. Just C.
C to the 1.
Okay.
What's in here?
Okay, be 5. C? Or just be 5?
Correct.
And then it'll be 2. Plus 2.
Do that final step.
Okay.
By the final step, I mean multiply 2 by 5c and make sure you get 10c squared, do you?
No.
Okay, so what do I got to do?
Put in the 2.
Put a c with that 2.
Okay.
Now,
Okay.
Now, if I multiply this by that, I get 25c, and if I multiply this by that, I get 10c squared.
Okay.
Okay?
Awesome.
So the key really is the multiplication here. It's not the division. I mean, it's nice to be able to do division. Let's go back a step here. I want to make sure that you're thinking about this correctly. Okay, what's going to go inside here? Well, what goes there is 25c divided by 5c. Well, that's equal to 5. I divide the numbers, I get 5. C divided by c is 1. 5. 5 goes there. Okay? Now let's do the second part. Let's divide 10c squared by 5c. Well, 10 divided by 5 is 2. C squared divided by c to the 1 is c to the 1.
Okay.
So that's what goes there. And so it's necessary to be able to know how to do the division. It really is. But the real key is being able to do the multiplication as your second step to make sure that you indeed have the right answer. And once you get to where you start doing that, you'll realize you don't really end up doing the division. At least I do.
Yeah.
You just end up doing the multiplication. Okay? Now what are my two solutions?
Okay, c is equal to 0. And then c is equal to negative 2/5.
Good. No, not good. Almost.
No.
Almost.
Okay.
Let's write it out. That's one of the reasons I think it makes sense to write it out. By writing it out, I mean starting from this step here. Now, you were pretty close in your answer, but because you tried to do 2 steps in one, or actually 3 steps in one.
Well, I didn't divide the, I divided the
Do it
remainder.
step by step. What's the first step here?
Subtract the 5.
So that gives us 2c equals minus 5. And now the next step?
Divide by 2.
Okay.
So c equals 5 over 2. Okay.
So you just had it the reciprocal is all.
My bad.
Well, it's an easy mistake to make if you try to do all 3 steps in one. That's why it's a good idea to write it out.
Okay.
Myself included. If I was taking an exam and my life depended on it, you better believe I'm going to write this out. I'm not going to try to jump from that step.
I think the reason I did it is because with the rest of the equations, the variables on the opposite side on the parentheses.
Okay, that's fine.
Okay, next one is 18q minus 2q to the power of 2 equals 0.
Okay. Factor that.
Okay, would the highest number be 2? And then it would be q. And then on the inside, it would be 2 divided by 18. That's 6, right?
18,
no,
18 divided by 2.
It's 9.
Okay.
And then minus would just be q.
Uh-huh.
Okay.
So my solutions again?
Okay, so it'd be q equals 0. And then it would be okay, so you would subtract the 9, and then it would go to the other side.
Let's talk about solving that equation right there.
Okay.
What's the easiest way to solve that equation? Is it to subtract the 9 from both sides?
Yes.
Not really. What happens if I do that?
Look
I
at the
end up
negative.
with this. Minus q equals minus 9, and then I got to do another step. I got to divide both sides by minus 1 in order to get q equals 9. So you force me to do 2 steps. Well, I can solve this in 1 step. What do I need to do to solve it in 1 step?
You could just add the
Add
q?
q to both sides.
Okay.
In other words, q doesn't need to be on the left. Your variable can be on the right, and it's just as valid and sometimes quicker. This was one step as opposed to two steps. But it left my variable on the right side, but that's okay. Learn to be comfortable with having your variable on the right side. There's nothing in algebra that says you got to have the variable on the left.
Okay.
Yeah?
Awesome. Okay. 3n to the power of 2 equals 9n.
Okay.
Okay, so it would be 3n.
Well,
right?
what's my first step? Notice this is not my typical looking equation.
Oh.
Most of my equations, I got 0 on the other side.
Would you move the 9 over to the n by subtraction?
Yes. And there's one step here that's very important to avoid. And that's to divide both sides of the equation by n.
Okay.
If you do that, in fact, let's go through that solution. Let's say I'm going to divide both sides of this equation by 3n. Well, that answers my entire problem. That means n equals 3. I'm done, right?
Right.
I missed a solution. There's another solution, n equals 0. And why did I miss it? Because I divided both sides of my equation by n, and you cannot divide by 0. And yet, so when you divide by a variable that could be 0, and it's actually one of the solutions, it disappears. So if we go back and do this the proper way, which is to subtract 9n from both sides, well, what's left on the right? 0. If I subtract 9n, I'm left with 0. Now we have the same kind of problem we've been looking at the whole lesson. Let's factor this.
Okay, so then it would be 3n. And then on the inside it would be n, right? And then it would be minus 3n. Or just 3, my bad.
You see why it's just 3?
Yeah.
Okay. Now let's solve it.
Okay, so n equals 0.
Ah, we got it this time.
And then you can add the 3. So it'll be n equals 3.
Yeah. We were expecting two solutions. This is where it's kind of helpful to know that when you're looking at a quadratic, you generally have two solutions. So if I make a mistake and solve this incorrectly, and I only come up with one solution, that should be a red flag. It should be a flag indicating that maybe I made a mistake if I only came up with one solution to a quadratic. But notice when I do it properly, I don't lose this solution of n equals 0. And clearly, n equals 0 is a solution. If n is 0, 3 times 0 squared is equal to 9 times 0. So 0 is a very valid solution to this thing.
Okay.
So this is a real easy one to make that mistake on. Just always remember that you don't want to be dividing both sides of an equation by a variable if that variable can be 0.
Okay.
Because if it is 0, you're going to lose it. You're going to lose that.
Okay. Okay.
Definitely cost you points on a test, guaranteed. If that was a 2-point problem and you only came up with n equal 3, you'd have lost a point.
Yeah. Okay. Negative 28r.
Negative 28r or just 28r?
Negative. Sorry. Equals 4r to the power of 2.
Okay.
So, would you subtract, or you could add the 28r on the left side to the right side?
I would add, because positive coefficients are preferable to negative coefficients.
Okay.
In other words, if I subtract this, here's what I'm left with. Both coefficients are negative.
Okay.
Whereas if I add 28r to both sides, then I'm left with this. And like I said, as long as you're comfortable with having your variable on the right side, positive coefficients are easier to deal with than negative coefficients.
Okay.
Now let's factor this.
Okay, so it would be 4, right? The largest. 4r. And then on the inside it will be 1r. And then it'll be plus 28, 8, right?
7.
7.
So what's your solutions?
Okay, so then it'll be r equals 0, and then r equals negative 7.
Okay. Now, hold on 1 minute.
Okay.
Because it's, sorry, I forgot to do something first. Because it's been 3 weeks,
My brain's not fresh.
well, nobody's brain is fresh. My brain isn't fresh. You're only my second tutoring session since the holidays. So when that happens, go to A+ Math and checkbox that, and that. Notice I don't care about the 2 by 1. I don't care about the 2 by 1 there. What I'm wanting you to practice is your addition, subtraction, multiplication, and division of single-digit numbers.
Okay.
So let's just do it for 5 minutes just so that I can show you what I'm talking about. Answer these as fast as you can.
Negative 28. Okay, so it's like plus, right?
Yes.
Okay, so then it'll be just 14. Okay, and then that would be 0. That would be a negative, and negative's a positive, right?
No, what's the answer?
17?
Negative 17.
Negative 17, okay.
Because it becomes negative 9 plus a negative 8.
Okay.
This is division.
Okay, 3 divided by 18. 5?
This is why I wanted to do it, because I noticed you've been off a little bit on your multiplication and division tables. And that's you got to fix that before you fix anything else. Right?
Okay. Right.
You can't be dividing 18 by 3 and coming up with 5. If you do that, you will never get past algebra. In other words, you've got to be a master of arithmetic, single-digit arithmetic, to get past algebra. Even though I understand you got a calculator sitting there, and you could get by with that calculator, and you think you could, but in reality, you really can't. There's just too many little operations to do. In a typical algebra equation, you might have to do 6 or 7 single-digit operations. You don't want to have to do all 6 or 7 of those on a calculator. You don't want to have to do 5 minus 2 equals 3 on a calculator. Right?
Okay.
So it extends all the way up to things like 18 divided by 3. You want to know that that is 6, and that you want to be 99% accurate on that.
Okay.
Okay? It's just one of my opinions about the key to being good at math. It starts with being good at this. And this is easy to get good at. You can do this entirely on your own. You don't need my help. is all you need to do is to put a little practice into it, a little drill time.
Okay.
If you find yourself being a little rusty on some of your arithmetic, then spend 5 minutes a day on this thing.
Okay.
Okay? All right, let's go back to your problems. What else you got?
Okay, it's a word problem.
Okay.
Well, no, it's not a word problem.
First of all, let me ask you a question. Have you had any kind of problems like this?
No.
Okay, that's common. This
Okay.
is what's next, is factoring quadratics when you have a constant, and you cannot take a greatest common factor out.
Okay.
Let's stick with what you're dealing with now.
I don't know if I can verbalize it because it has a graph.
Okay. Read the problem. Maybe I can figure it out.
Okay, it says the entrance of a tunnel can be modeled by y equals -11/50. And then in parentheses, it's x minus 4. And then in a separate one, it is x minus 24.
Okay. That is a quadratic.
Okay.
The reason I know is because when I multiply these two things together, I'm going to get an x squared as my first term.
Okay.
Okay, that makes it a quadratic.
Okay.
Okay. Another thing to know about quadratics is they are parabolas. They look like that or they look like that. That's it.
Okay.
They don't ever look like this. They're either a vertical parabola that opens up or they're a vertical parabola that opens down.
Okay.
So the fact that we're talking about a tunnel here makes all the sense in the world. There's our tunnel shape right there. It's the parabola. The shape of that tunnel is this quadratic right there.
Okay. So it wants me to, it says find the width of the tunnel at ground level.
Okay.
So I can give you the numbers it gives me on the graph.
Well,
it's
hold on a second. Let's talk about quadratics in general.
Okay.
Let's talk about a real simple. If I told you that x minus 2 times x minus 4 was equal to 0, and I say graph that, well, I know it's a quadratic. I know it's a parabola. The question is, where does it go through the x-axis? What are my 2 points?
It's -4, -4.
Actually, +2 and +4. Remember, we're going to set each of these equal to 0.
0.
So
Okay.
x equal 2 is a solution. So my parabola looks like this. So if you give me a quadratic that's already been factored, I can figure out where it crosses the x-axis.
Okay.
Okay, instantly. Now, back to the problem you gave me, we know that's a tunnel, and well, let's talk about one other thing. If I have a quadratic like this, positive coefficient there, that means it opens up. Negative coefficient there means it opens down.
It's a negative coefficient on mine.
Right. Negative 50 divided by 11, right?
Mm-hmm.
Negative 11 divided by 50. That tells us that we're going to have an upside down parabola. Before I see anything else, the moment I see that, I know we're looking at this kind of a parabola, which is fitting because they're talking about a tunnel, and a tunnel is shaped as an upside down parabola. Okay? So if I were to draw an xy coordinate plane on this function like that,
Mm-hmm.
I now can say that my two intercepts are at 4 and 24.
Okay.
That's my parabola. So the width would be
And it goes up to 24 too.
20, yeah. In other words, this distance here is 20, the distance between the two x-intercepts. No, there's something else that I was missing from this problem. Read the whole problem to me. Or is there any information on the graph that I need?
The height goes up to 24.
Okay.
It wants to know how tall it is, so would that just be 24?
Yeah. At the center of the tunnel, it would be 24. Okay. Let me think about this for just a second here. Notice that the halfway point here is not 20, it's 14, right?
Yes.
So when x equals 14, y is going to equal this point right here, hopefully 24 if we've done everything right. Well, let's substitute 14 for x and see if that's the case. Minus 11/50 times 14 minus 4 is 10, times 14 minus 24 is minus 10. Well, minus times minus is plus, so we have 1100 in the numerator, and we have 50 in the denominator. Guess what? That's 24.
So it's the height is correct then?
Yes. So the height is 24. In other words, the graph that I've drawn fits this equation. This quadratic fits this picture where this parabola goes through the x-axis at 4 and 24, and the height is 24 units above the x-axis.
Okay. That makes sense.
Okay. Did they ask anything else about this?
Nope, that's it. Do we have time for one more like this?
Yeah.
Okay. It's y equals negative 2 over 315. And in parentheses, it's x plus 315. And then the other one is x minus 315.
Let's go ahead and see if we can figure out how to draw this graph.
Okay.
Because you need to be able to, given a quadratic, you need to be able to draw the graph. Where are my x-intercepts? In other words, where does my parabola, first of all, is my parabola point down or up?
It's going to point up.
This is negative.
Like an arc.
When that's negative, it points down. In other words, it's this kind of a parabola.
Okay. Sorry about that.
If it's positive, it points up. So that's the first thing you want to realize about quadratics is, does it point up or down? Well, it points down. What 2 points is it going to go through the x-axis?
Negative 315 and positive 315.
That tells me a lot. That means, whoops, now I know almost everything there is to know about this parabola. Goes through that, goes through that. The only thing I don't know is the y value right there. How do I solve for that?
Would you...
In other words, I'm sure that's the question here, right? How high?
Oh, yeah.
How high?
It's x minus the arc, and then what's the width of the arc?
Okay. Well, the width of the arc is pretty easy. That's 630.
30. Okay.
But figuring out what y is there, what do we have to substitute for x in order to figure out what y is in that? What is x at this point right here?
X?
Yeah, what is x right there?
0.
It's 0, right?
0.
Makes it real easy. That means is all we have to do is substitute 0 for x and we have our answer. Well, that's 315. That's minus 315. What's a quick way to come up with that answer right there without a calculator?
I don't know.
Well, let's try to simplify it. I can divide top and bottom by 315, so that 315 cancels out with that, right? 315 divided by 315 is 1.
Okay.
Now, the only thing I'm left with is the minus 2 times minus 315. That becomes plus 630. That's what this is right there, 630.
So it'll be 630 across and 630 high?
630 high, yes, and 630 across. You're correct, yes.
Okay. Awesome.
All right. Connor, that's good. I feel like you're understanding this stuff pretty good.
Awesome. Thank you very much.
Yeah, you don't want to get behind. Staying ahead of the game is the answer for sure. And like I said, what you have coming up next week, I'm quite sure, will be quadratics where you have constants. And that's a whole different ballgame. Mm-hmm. In other words, when you have something, I'll just give you a sneak preview real quick.
Okay.
When I have something like this, I can't take a greatest common factor out of that. But I can factor it into x minus 2 times x plus 1. That, when people talk about factoring, that's the kind of factoring they talk about. That's the most common kind of factoring you're talking about. This is the difficult factoring here. The factoring we were working with today is pretty much fairly easy. Whenever it's a question of just finding a greatest common factor, it's pretty easy. But this kind of factoring is a little tougher. But I've got some secrets on how to do this. Every school tends to teach these differently on how to do this kind of factoring. And I kind of have my own technique. And it works really, really well. So that's what we'll probably be doing the next time we talk.
Awesome.
All right, Connor. Talk to you later.
Okay, thank you so much.